Hello and welcome to our channel again, Bit Astro here, and now we are going to discuss about another mathematical physics topic, the ordinary differential equations. And this topic is related to the differentiations, and why it is related to the differentiations we will discuss here. But first of all, this ordinary differential equations, why arises, and all that things we are going to discuss, so that there is some sort of thinking that why we study these particular types of differential equations. We have studied the linear equations, but what are these particular differential equations and what is ordinary in this particular differential equations? So here I'm Suraj, and now let's start our video on the ordinary differential equations, and I will start this video from the beginning of that why the ordinary differential equations arises in the field of physics, and in mathematics also why this is important. And after this I will start our teaching on this particular ordinary differential equations topic. So now let's start our video on this particular topic. So first of all, we will discuss about these differential equations and why it arises in the physics. So in class 10th, you have studied the linear equations in two variable or linear equations in one variable, okay, generally. So what do you mean by the equation? So it's a very common thing that the equations is the collection of some sorts of variables, and so suppose that x plus y is equals to 1, and there is an equal to sign there equating to the 0, and we can write it as x plus y minus 1 is equals to the 0. Okay, so this is a typical definition of the equations contains the equal sign, it contains the variables, and we have to find out the variables. Okay, so this is the first thing in the equations. But what are these particular differential equations? Okay, so what this particular differential equations are? So the thing is that, as we all know that what a differentiation is. Okay, so differentiation is basically the finding the curve of finding the tangent of a curve. So this is basically the meaning of the differentiations, or it can also be used to describe the relationship that how a particular quantity is changing with respect to some another quantity, and that's how we represent it. Suppose that there is a displacement. Okay, so in this case of physics, so displacement is there. So if someone asks you what is happens when we take the differentiation of the x with respect to the time, it means it is equal to the velocity. It means here the differentiation means is that it is describing that how the particular position is changing with respect to the time, and this is how we can describe the velocity of the particle. But this case is only useful when we are using that the velocity is increasing at a non-uniform rate. Okay, non-uniform, not a uniform rate, because if there is a uniform rate, there is a constant. If there is a uniform rate, okay, so it means that the displacement is not increasing in a uniform rate or decreasing in a uniform rate. That's what typical the differentiation uses, because as you can see here that suppose that there is a graph of this particular velocity, time velocity graph. Okay, so whatever, any type of graph. So if there is a line which is just like this straightforward, okay, so there is no meaning of finding the dy by dx of this particular quantity, because the curve is constant all the time. The curve is constant all the time. Suppose that this is a velocity time graph, so the velocity is constant at all time. So in this case we are not going to use the differentiation, because the velocity is constant. Then why we use this particular thing, which is only useful when we are describing this type of things, like we are describing the phenomena where the velocity is like this, or the velocity is like a decreasing or increasing, and we do not know exactly at every point, at every single point, here the velocity is changing with respect to the time. So how we can describe these types of phenomena is by the differentiations, and we will discuss differentiation in detailed topic in later videos. But today our video is going on to be this ordinary differential or the differential equations. So what the basic meaning of the differential equation is that any equation that contains differentiation. Suppose that I have this particular equation, that dy by dx is equals to the 0. Okay, so this is a particular one type of so in this situation you can see that it is an equation. Okay, so it is an equation, but it is not like a linear or equation in one variable or the two variable. It's a differential equation. So any equations containing derivatives, containing differentiations, It means we can clarify this like this, is that this is a very important thing that you have to know, that these are not the ordinary things. Okay, so any equations that contains the derivative, so derivative can be written as d by dx. Okay, so any equations that contains this type of derivative of a function with respect to any other quantity, and here it is dx. Okay, dx is what known as the differential equation, this is the basic thing, that any equations which contains the derivative differentiation, as you can see here, dy by dx, this is a sign of a differentiation, it means this is an differential equation. Okay, that's fine. That's just like this. I have taken here that x plus y is equals to the 1. So it is also an equation, but it is an equation which is like a two variable. Okay, so this is also an equation where you can find out the satisfying value of x and y so that it become 1, satisfying value of x and y, just like this, where you find out the value of x and y for which the value of this plus will become 1. So there can be any of the systems of solutions of this particular equations that satisfy these equations. Okay, so just like this, the solution of a differential equation is the solution of a differential equations is a function. This is a differential equation. Okay, so what's its solutions represent? So what is solution represent? Suppose that I find out the solution of this particular equations by the method of integration. Okay, so how we can find, we will discuss here, but suppose that we found out the solutions, what does this solution represents? What is the thing here? It is same as in the linear equation in one or two variable that we typically study in the class 10th. So yes, it's a correlated with each other. By solving a differential equation, you get that of what value of y, suppose that y is a function, maybe y is a constant, maybe y is a function of x on y, so let's say it's function of x and y. So what type of function of y, it means let's say y of x is equals to 2x squared. Okay, for this scenario I am not taking, because from this scenario it is not true. Okay, I am taking any arbitrary thing. Suppose that there is a function here, so there is a function. How can you differentiate the function with how can you differentiate it? So differentiating it with respect to y will give dy by dx is what equals to the it's equals to the, I think, 4x. Okay, so this is the differentiation of this particular quantity. Okay, so this is the thing, or this is the differentiation of the 2x square. Now what we are going to do is that if someone asks you that what is the value of y here, suppose that you differentiate a function and gives us that, yeah, 4x is the differentiation of this particular yx function. But if someone asks you that this particular equation is only true for some only one value of y, it is only true one value of y, so this is a differential equation. You have to find out one value of y. Okay, so you have to find out that what value of y when you will differentiate with respect to x will give 4x. So this is the basic thing. You know that it is very similar to the linear equation. In linear equation, you have to find out of what value of x and y the sum becomes 1. So just like this here, of what value of but here is a function. Okay, it's not because function, because it is differentiation is only occurs when there is a non-uniform things. It means something is a function of different things, it means it is dependent upon each other. So we can say that the method or the methodological thing that we have to do in this particular thing is that we have to find out of what value of y when we will differentiate with respect to x will give this particular thing or this particular thing. Okay, so this is the thing that what means that when you do the solution of the differential equations. Okay, so how you can do this? So this is a very simple integral that you can do it, but we are going to discuss that how we can solve this. But I am trying to say that you understand what the differential equation is. Yes, differential equations is the collections, or you can say that equation which contains the derivative. For example, dy by dx is equals to 0, dy by dx is equals to the 4x. These are the differential equations. Okay, what's the solution of the differential equation represents? So solution of the differential equations means of, suppose that here, of what value of y if I differentiate with respect to x will give 0. will give 0. This is the solution of the differential equations. And okay, we have understood that what is differential equation, what the solution of the differential equation represent. It represent that if y, suppose that here y is any function that you differentiate with respect to the x. So y is any function which is y is equals to the constant. Okay, so y is simply any of constant 1 2 3 4, any of the arbitrary constant y can be. So what will happen if you differentiate a constant with respect to the x? So differentiation of a constant is equals to the 0. It means in this case the solution of this particular equation is y is equals to the c. You understand what the solution represent? So in simple words, solution represents that what type of value, when you will put down the value of y in this particular operation, what's the y value should be so that it is equals to the 0. So in this case, what's the value of y so that the equations become 4x? So this is the solution of what the differential equations represent. So now what we are going to study is about that why differential equations. So differential equations occurs because you know that in the world everything is changing, everything is dependent upon each other. Velocity is dependent upon time. There is a non-uniform, or you can say that velocity is a function of time. Everything is changing and dependent upon each other, and that's why the differential equation arises, because differentiation describes the rate of change of any quantity with respect to some other quantity. Okay, I know that you haven't studied the differentiation, and I also do not taught the differentiation, but when I will teach you the differentiation, then you can understand that what's the importance of the differential equations. Okay, how differential equations can represent. So for now, we are more focused on the solutions of the differential equations, that how we can find the solutions of the differential equations. So now we are going to discuss today one method that how we can do this. So our first method of doing the differential equation solutions, first solution, sorry, which is can be found out as a separable solution. Separable method or separable solution, you can find out. This is the first method, so that you can find out that particular quantities. So what's the thing is, if anyone will give you a differential equation of this type, okay, remember this type, dy bata dx is equals to the f of x into g of y. So if someone give you this types of equations and ask you to find out the required value of this particular constants, this particular y, so that these equations become this. So the equation of this type, there are various types of the differential equations that can exist. So I am taking one of the very simplest of the differential equations, which is dy by dx is equals to f of x into g of y. Okay, so how can you find out? So finding out this particular thing, so how can we find out the differential equations of this particular thing? So solution of this differential equation can be found out by separating out the y term and x term. So separating out the y term can be written as dy upon gy, because g is the function of y, so we'll put down here y, and f of x into the dx. Okay, and this is the thing. And after this, how we can find out? Just integrate on both sides. Just integrate on both sides, and you will left with a value. We will left with the solutions of this particular differential equations. Integration of f of x into the dx. So this is the very fundamental way of deriving a very simple differential equations. So here is an example. Okay, so I will take you example so that you can understand it in a better manner. So let's take any of the differential equations. I will take dy by dx. Dy by dx is equals to the, suppose that I think yeah, let's take it as 6x cube. So this types of equation is given, so you can see that this is equivalent to this particular equation. But the thing is that here there is only x term, not y term. Okay, so there is no any type of the that's terrifying things. Okay, this solutions, this can be also equivalent to the condition when there is only one type of function given. Separable solution can also be find out if there is only one kind of solution given, f of x. For this type of differential equations, you can also find with this method, and for this type of differential equations, you can also find. It means these two can be found out by this particular differential equation. So if someone asks you Okay, find out the solution of this particular differential equation. What you will do is that you will separate out the terms. Just I have did here that you put dy here. Dy is what equals to the 6x cube and here dx. Okay, so 6x cube into the dx, and just integrating on the both side. So integrating on the both side, it is equals to the dy is equals to the 6 can be taken out from this integration sign, and this is equals to the x cube into the dx. Okay, so now what we are going to do next thing is, okay, so the next thing that we are going to do, what's the integral, or you can say that what is the particular the integral of dy. So the integral of di is y plus any of this particular constants, let's say, and you know this c1 c2 whatever this particular constant is, and this is equals to the, so here is y plus constant, where c is any arbitrary constant, which is the constant integration which came up. Okay, now the integration of x to the power 3 is equals to the x to the power 4 divided by the 4 and plus here and any arbitrary constant, such that you can define this. Okay, so this is I think let's say it is c2 and this is c1. These are the two different constants of the integration. So now we can do is that we can y is equals to the 6x4 by 4 and plus c, where let's remember that here I've written that c is equals to the c2 minus c1. So this is the particular solution of the differential equation. Okay, so this is the particular solution of the particular differential equations, what we call, because if you put down the value of y is equals to the x to the power 4 upon 4 in this particular integral sign, what you will get to know is just exactly this. Okay, so if you differentiate this function you will get this. So the solution is just reverse. You have to find out this particular y function. So this is the first method for solving a differential equations, which is by the separable solution. It means what we do is that we just separate out the x term and y term in the differential equations, integrate it, and get our the particular solutions of our integrals. So this is our first introductory video on the partial differential equations. Sorry, it is an ordinary differential equations. So in the next video, we are going to discuss about some other methods of solving a particular differential equations. And after this, we start not an ordinary, a partial. Oh, okay. First of all, I have to clear your doubt that what is the ordinary and the partial differential equations. So ordinary differential equations are those equations which contain normal d by dx. And what is partial? So if you recall my videos on the partial derivatives, I have encountered that d by dx symbol, which is an ordinary differentiation symbol, is not used when there is more than two function. When there is more than two function, this is not used. More than two functions, let us say more than two function, this particular is not used. In this case it is used what's known as a partial derivative. Okay, so just like this, when our differential equations, you can say that when our differential equations contains very this is the same analogy to the partial derivative. Just like this, there are the partial derivative ordinary differential equations and ordinary differential equations, and both have different methods to solve. So partial differential equation is some sort of very advanced topic, and the ordinary differential equations is what the basic topic. So we'll discuss this when we study the some of the deep quantum mechanics like the harmonic oscillator or deep understanding of the Schrodinger wave equations, because the Schrodinger wave equation is also a partial differential equations of this second order. Okay, so we have to understand that's what equations means, then we can start our quantum mechanical lecture. And this has very profound uses, because when we come to the hydrogen atom quantum mechanics, it means when we see that how can we describe the hydrogen atom with the help of the Schrodinger wave equations, it contains some very famous differential equations like the legendary polynomial, which is the solution of the legendary differential equations, Hermite polynomials and all that thing. So these types of things came when we solve various types of the differential equations. So hydrogen atom is one such type of a differential equations. So today's this is my video on the first topic and the first part on the ordinary differential equations, and maybe in the next video we will start at our next topic or the some other methods for solving the different types of the differential equations. So thank you for watching my video.